All right, we're going to go over the next part of the test review. Starting with number one, it says which of the following tables represents an exponential relationship and select all that apply. So remember, when you see this phrase, select all that apply, that is telling you that there is going to be at least two correct answers, if not more. So first of all, if I'm looking for an exponential relationship, that means I am consistently multiplying by the same number every time, or I'm consistently dividing by the same number every time. So looking at num on answer choice A, I'm looking what's happening on A is each time we are not multiplying, but instead we are subtracting by 7 each time. So A is not an exponential function. Looking at B, on B, when I look from uh, down the Y column, I see that consistently we are adding 1 each time. So again, that is not an exponential relationship either. So if you consistently go down by the same amount or you consistently go up by the same amount, that is a linear relationship. Looking at part C, so let's see, when I go down here, looks like times 3, times 3, times 3, and times 3. Yes, this one is an exponential relationship. And let's see, let's look at this one. This one's kind of weird. Down 4, down 1, but then up 1, and then up 4. So this is not an exponential relationship because we are not multiplying or dividing by the same number every time. We are not even adding or subtracting by the same number every time. That we will learn later on is a quadratic relationship. All right, let's look at choice E. I'm going up 5, up 5, up 5, up 5. So that is linear. And now choice F. It might be a little difficult to see this one, so sometimes it might be easier to start at the bottom and work your way up. Divide by 5 every single time. We are dividing by 5. So dividing by 5 is the same thing as multiplying by 1/5. So F is an exponential function. All right, let's look at now number two. Again, we are looking for which graph is an exponential function. Now, an exponential function graph is either going to look like something like this, or it could go down like this. Okay, so it's a curve like that, but it's either going up or it's going down. So let's look at the first one. Clearly, that matches the shape of the graph. So A is exponential. B is a line. It is not a curve, so that is not exponential. C is again a flat line, so no, that is not exponential. D is the curve, but it's going down. That's fine. Okay, E is again a line, so no, that is not exponential. And F, it is a curve, but it's a curve that goes down and then up. That's what we call a quadratic function. You will learn that later this school year. All right, let's continue on to the next problem, number 3. It says, which of the following tables is correct for the function y equals 15 times 3 to the x? So first of all, we have two key numbers that are going to tell us about our tables. This first number tells me that I need the point 0.015. So let's look. Do I have 0.15 yet? Unfortunately, I have 0.15 in every single table, so that doesn't help me eliminate anything here, 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 and here. So nothing's going to happen there. Nothing's going to eliminate. And then we look at the 3, and this is what we call the multiplier. So we are going to consistently multiply by 3 as we go down. So looking at A, nope, that is going up by 3 every time. So that doesn't do it. So let's look at B. B, you might not be able to tell that first one, but I can see that one's times 3. That one's not times 3. Not sure what's going on there. So, nope, not gonna do it on that one. That one's kind of just weird. All right, C. No, looks like times 3 at first, but not here. So that's a little weird. Nope, that's not it either. Okay, and then D, we have to consistently be times 3. So here we go. All of these are multiplied by 3. So this is it. D is the correct answer. So that matches the table. Okay, let's look at now number 18, number 4. So number 4, again, we see this is the y-intercept. We are going to contain the point 0.018. Unfortunately, that does not eliminate any of the answer choices because all of the tables have 0.18. Okay, multiplying by 1/3. Multiplying by 1/3, which is really the same thing as dividing by 3. All right, so if we're multiplying by 1/3, first of all, the thing is the numbers are going to go down. So it can't be A and it can't be D because those numbers are going up. Now, B is going down, but it's going down consistently by the exact same value. It's not being multiplied or divided, it's being subtracted. These are all subtracted by 3, so it can't be B. So C, we're looking for dividing by 3. Sometimes it helps to start at the bottom. 6 divided by 3 is 2. 18 divided by 3 is 6. 54 divided by 3 is 18. And 162 divided by 3 is 54. Remember, if you're not sure, you always have a calculator that you can use on that one. But C is the correct answer. All right, let's look at number 5. It says which of the following tables represents an exponential growth relationship? So we have exponential and growth. So growth meaning it's going to go up. So it can't be A and it can't be D. So it's E and it can't be, it looks like it cannot even be B. They're all going down except for C. So and then the question is it really exponential? Well, 10 times 4 is 40. 40 times 4 is 160. And 160 times 4 is 640. So C is an exponential growth. All right, looking at number 6, which of the following tables represents an exponential now decay? So decay means it's going down. It can't be A and it can't be C, but it might be B and it might be D. So we have to look and see. Decay means we're going to either multiply by the same fraction less than 1 or we're going to divide by the same number. So I'm looking at this and I'm seeing on the first one, we're just consistently going down. We're subtracting by 3. So that's not exponential when you're subtracting by the same number. All right. And then on D, if we divide by 3, 261 divided by 3 is 87. 87 divided by 3 is 29. 29 divided by 3 is 29 thirds. So D is the correct answer. All right. Number 7, it says which of the following equations represents exponential growth? Now, an exponential growth function looks like this. Y equals A times B to the X. So that means A and B are definitely not correct because those are linear. A and B right here, these are in the form Y equals mx plus B. So those are linear. These are linear. So it's either C or it's D. Both are exponential, but one of them is growth and one of them is not. So this number tells me what the multiplier is. The multiplier on this one, this is 1/5, whereas the multiplier on this one is 8. So multiplying by 1/5 is really the same thing as dividing by 5. This is a decay. We want a growth. Multiplying by 8 is going to grow the function. All right, let's take a look at number 8, which of the following again represents exponential decay now. Exponential and then decay. So A and B are not correct because those are linear, just like in the last example. Now, if I look at C, this is your multiplier is 2. So multiplier is 2. That's going to be a growth. I need a decay. Multiplier by 1/5, which is, by the way, the same thing as dividing by 5. So D is the correct answer. All right, let's look at number nine. Which of the following situations represents exponential growth? Okay, so if we're having an exponential, we're multiplying, and if we're growing, we're going up. Okay, look at A. The amount of radioactive material in a mixture is cut in half. Well, cutting something in half is not growing it, so it's not A. B. A pool is filled in the amount of is filled as a pool is filled, the amount of water rises by 7 inches each hour. So this is rises by seven. It does go up, but it goes up by a consistent amount every time. We are adding 7 inches to the depth of the water, not multiplying. So this is not B either. Okay. C, on a trip, the amount of gasoline in a tank decreases by 3 gallons every hour. So now what's happening is that the tank level is decreasing meaning subtracting. We don't subtract an exponential. And then D, the value of the paint doubles every 20 years. Doubles. That means it's going up, but it's multiplying by two. So D is the correct answer. Okay, let's look at number 10. Which of the following situations represents an exponential decay? Exponential again means we are multiplying or dividing. Decay really means we're dividing. We're going down and we're dividing. Okay, so let's look at A. The population of the country doubles. Nope, that's exponential, but that's going up. I need it to rise to decrease. B, the cost of the power bill increases by 12 cents for every kilowatt hour. That's a linear relationship. It's going up, but it's linear if it's going up by the same amount every time. C, the value of the car is cut in half. There you go, right there. Cut in half. That is a decay problem. Okay, and then D is not correct because it decreases by the same amount. That's a linear problem. Okay, number 11. An invasive species insect has entered an ecosystem. The population of the insect is expected to double every month. There are currently 450,000 invasive insects in this ecosystem, which in equation represents the population of the insect P in terms of the number of months from now. So this is kind of the starting amount. So remember when we write our equation in exponential function, it's y equals a times b to the x. A is the starting amount and B is the multiplier. The starting amount is 450,000 and the multiplier, since it doubles, is 2. C is the correct answer. All right, number 12. Oh, looks like there's a 1 stuck in here somewhere for some reason. Sorry about that. All right, let's look at this one. It says an exotic species released into a wilderness released into the wilderness. This species is not native to the wilderness. The result is that the insect began dying off at an alarming rate, so that its population was cut in half every year. Okay. So it says at that point, the exotic species was released. The population of the insect was 5 million. So 5 million is your starting value. Let Y represent the population of the insect and X represent the number of times, the time in years, excuse me. Write an equation to represent this situation. So again, remember, exponential functions look like this. Y equals A times B to the X. So your starting amount is 5 million. Okay, there is a little mistake in this problem. There's two little zeros here. This should be 5 million, not 500,000. All right, and then, okay, 1/2 is our multiplier. So A is the starting amount, 1/2 is the multiplier, so that would be C. But of course, we needed this little correction. All right, let's look at number 12. What is the equation of the table below? All right, so first thing we should recognize is what is happening here. Well, every time we're multiplying by 12. 5 times 12 is 60, 6 times 12, 60 times 12 is 720, and 720 times 12 is 8640. So our equation is exponential looking like this. Our starting value, which is really our y-intercept, is 60. Since we're multiplying by 12, our multiplier is going to go in for B. So the correct answer is A. Okay, number 13. What is the equation of the table? So on this one, first things first, here is our y-intercept. So there is our A value. Our B value, what's happening here? Looks to me like they're dividing by 4. So if you use your calculator, 464 divided by 4 is 116. 116 divided by 4 is 29. And 29 divided by 4 is 29 over 4. Now, dividing by 4 is really the same thing as multiplying by 1/4. So D is the correct answer. All right, number 14, what is the equation of the graph below? Well, the first thing I'm going to see is that if you look at the way this is counting, each tick mark is 2 on the y-axis. So that dot is occurring at 6. So A equals 6. Now we got to find some perfect points here. So I'm looking for a few perfect points. And we could kind of make a little table if we wanted here. Here's our X, here's our Y. So I have 0, 6, 1, let's see, 8, 10, 12, and 2. Let's see, that would be 24. So if you look at what's happening here, we're multiplying consistently by 2. So our B value is 2. Our A value is 6. So that is D. All right, number 15. First thing I know is that this is a decay problem because it's going down. So it can't be C or D. It's got to either be A or B. So when I look at this one, I see right here, it crosses at y equals 2. So there is the number. Now, if you wanted to check a little bit further, you could find some perfect points here. So I'm looking at, let's make our little X and Y here. At -2, the Y value is 18. At -1, the Y value is 6. At 0, the Y value is 2. So if you look and see what's happening here, we're dividing by 3, which is the same thing as multiplying by 1/3. So A is the correct answer. All right, number 16. The population of a city is 9,500. The population is expected to grow at a rate of 13% per year. Which of the following equations represents the population of a city, P, in terms of the number of years since now, which is N? All right, so the starting population is 9,500. Unfortunately, all of the answer choices start with a 9,500. Now, that 13%, if you are increasing by 13%, then you are multiplying by 1 plus 13% or 0.13. So that would be 1.13. So that gives us a D. Okay. If this was not growing but decreasing, then instead of the plus, I would use a subtraction. All right. Number 17. Giselle buys a car for 26,000. That doesn't eliminate any answer choices. The value of the car is expected to decrease at a rate of 18% per year. So I'm looking at 1 minus 0.18, which is 0.82. So my equation is going to be C. All right, number 18. Malachi opens a savings account with a starting balance of $8,000. The account has An interest rate of 4% per year compounded monthly. Okay. So starting balance of 8,000 doesn't help us at all. Compounded monthly means I'm going to divide by 12. 4% is 0.04 as a decimal, so it's not C or D. All right. Now, if it's when we're opening up an account, um, it's the balance, it's a savings account, actually. So this is going to be a growth. I need a plus sign here. So B is the correct answer. All right. And number 19, it says from the previous problem, what is the balance of Malachi's account after 7 years? So we're going to need a calculator here. So I'm going to pull up my calculator. My calculator is going to look just a little bit different, I'm sorry to say, than yours. All right. Let me see here. All right. So mine's going to look a little bit different. That's okay. 8,000 times 1 minus 0.04 divided by 12, close parentheses, and then we need our exponent key, x to the y, raised to the, now we have to put this 12 times 7 in parentheses, or you could just know that 12 times 7 is 84 and push equals. So we should get 6,000. What? Lost my calculator for a minute here. Oh no, I got to do it again. Sorry about that. I lost it. All right, so it wasn't 6,000. I don't know where that came from. All right, here we go. So $10,580.11. It's 0.110. So we'll do 0.11. $10,580.11 after 7 years. All right, so all we were doing is taking this answer, putting it into our calculator. All right, so that concludes this review. Hopefully you paid attention to the things that you got wrong and go back and look at see what mistakes you made. So and make sure you don't make those same mistakes again on the test.